Bismillahirrahmanirrahim. Assalamu alaikum. Today we are going to study about our first chapter, and it is considered as chapter number 9 in your textbook, and chapter name is chemical equilibrium. Chemical equilibrium. So first of all, there is only one definition that you have to understand, that is, what are reversible and irreversible reactions, reversible and irreversible processes. What are reversible and irreversible processes? Reversible reactions are those reactions those take part in forward direction as well as in a backward direction. So reaction in which reactants are being converted into products and products are being converted into reactants simultaneously. ठीक है, साथ में मुझे जवाब देना, आपने रिप्लाई करना है, ठीक है, कोई बात नहीं है. सो रिवर्सिबल रिएक्शंस क्या होते हैं? रिएक्टेंट्स आर बीइंग कन्वर्टेड इनटू प्रोडक्ट्स and products are also being converted into reactants. Okay, on the other hand, irreversible reactions are those reactions in which only reactants are converted into products. Only reactants are converted into products. They never get back to become reactants. Okay, clear?
Yes, sir.
So I will give some differences between reversible reactions and irreversible reactions here on the whiteboard. Reversible and irreversible reactions. First of all, I write here definition: reversible reactions in which reactants are being converted into products, and products are being converted into reactants, This is our first point. Okay, this is our first point. Reversible reactions in which reactants are converted into products and products are being converted into reactants simultaneously. Okay, so irreversible reactions are defined as in which reactants are only converted into products. Converted into products. This is unidirectional. This reaction is bidirectional. Bi mean two. Okay, these reactions go in both direction, forward direction as well as in backward direction, and this is a unidirectional reaction. This is unidirectional. Number two, these reactions only exist in controlled environment. This reaction only exists in controlled environment. Closed environment. Okay, closed container. So you can say that it exists in closed system. Closed. In which products are not escaping from the system or reactants are not escaping from the system. Okay, so if you consider this reaction, I'm going to write here that if you have carbon dioxide, water here, and if it reacts with carbon dioxide present in the solution, it will give you carboxylic acid, that is called carbonic acid. That is a carbonic acid. It produces carbonic acid. Have you ever drink carbonic acid? Pepsi? Yes. So carbon dioxide is compressed into the water and producing and it produces carboxylic acid, that is called carbonic acid. Okay, so this reaction occurs in a closed container in the bottle. Okay, so it is also a reversible reaction. It is also a reversible reaction. Clear? Okay, so this is a reversible reaction, and this is only occur in closed system. Number 3 point, reversible reactions, these exist in a open system. If you just open this lid, if you just open the lid of a Pepsi bottle, what will happen to the Pepsi? All carbon dioxide will be emitted out, and there will be no reversible reaction left behind. This all of the carbonic acid will be converted into carbon dioxide as well as into water. Okay, from this example you can understand that in closed system reversible reaction occur. Okay, and on the other hand irreversible reactions occur in open system. So these are major 3 differences. I would like to write another difference between them, between both these 2 categories. Please number 4, equilibrium, chemical equilibrium exists. Okay, we will study about it. Okay, chemical equilibrium, what is chemical equilibrium, we will study about it. Okay, and equilibrium does not exist. Chemical equilibrium does not exist. Clear?
Yes, sir.
And the third one, whenever chemical equilibrium exists, the reaction never goes to completion. Okay, clear? So reaction therefore never goes to completion. And number 5, reaction never goes to completion. Reaction goes to completion. Reversible reactions never goes to completion, while on the other hand irreversible reactions always goes to completion. Reaction goes to completion. So if I ask the question in exam that write the difference between irreversible reactions and reversible reactions, if the question is given in the long part, so you have to write in detail. Okay, this question will have 5 marks in the exam. Okay, and if I asked you to give characteristics of reversible reaction, then you can write reversible reaction definition and all these characteristics, and then the example itself. Okay, you have to write example itself. If I ask only one question that give characteristics of reversible reaction. Okay, if I asked you to write characteristics of irreversible reaction, then you have to write all these characteristics and discuss with an example. Okay, so here is an example of irreversible reaction, that is number 6. Na, whenever you have Na, it reacts with Cl2, it produces 2NaCl. okay, you just can balance these equations, and in this reaction, in reversible reaction, you can give the examples from your textbooks or from any other source. Okay, so I'm going to write here one famous example, that is N2 plus 3H2 preparation of ammonia gives us 2NH3. Haber process. Okay, you can write here conditions. Okay, if you have those are different in different textbooks, but in your, I think in your book textbooks it is 200 atm and 300 centigrade in the presence of nickel in the presence of nickel. Okay, clear? I hope you have understand all this topic.
Yes.
Clear? So reversible reactions, that you should have to clear that reversible reactions goes in the forward direction as well as in the backward direction without changing the condition of the system. Without changing the condition of the system. For example, if you have glucose, if you have this nitrogen here, and if you have this hydrogen here, and if you react both this with each other, the ammonia will be formed. And later on, ammonia, when ammonia have enough concentration, then ammonia will collide with itself and will convert it into nitrogen and hydrogen. Clear? Okay.
Yes.
So both these reactions are occurring in a closed container. Okay, in which reactants, products, both are present. Clear?
Yes, sir.
Clear? Any doubt?
No.
Okay. So our next topic is chemical equilibrium. मार्कर ले आइएगा. हाँ, ओके. तीन चार उठा के ले आना. So next topic is chemical equilibrium. So most of time we see the state of chemical equilibrium. Before discussing chemical equilibrium, I would like to give some illustration here. That if you have two pots and both these two pots are connected with each other through such mechanism, and if you just open the lid and put the water in it, the water will cover the water from this pot will flow to the that pot until the level of both these water pots are becomes equal. Okay, so here is another illustration, another example, another pot, and you have created such systems that in which you put water and all the water flow down to this one container, and it becomes and level of the both pots becomes equal to each other. Okay, so here is another container in which you put the water and you just fill it with water. Sorry. Okay, so if you just put the water in it, what will happen? Water flow through this pot to this pot. Okay, so let us assume that we have here reactants and this is our products. This is our reactants and this is our product, and this is our reactants and this is our products. All these systems are in one state, that is called state of equilibrium. Clear? Okay, so whenever you define state, most of the student defines equilibrium like when the concentration of reactants and products becomes equals is called chemical equilibrium. This is not a good definition of chemical equilibrium. So you have to define chemical equilibrium with respect to rates, not with respect to concentration. Okay?
Yes, sir.
Clear?
Yes.
Okay?
Yes.
So reactants are equals to products, reactants are smaller than products, and reactants are much greater than the products. So there can be a state of equilibrium. There can be a state of equilibrium in which reactants are greater than products, the amount of products are greater than reactants, or the both amounts can be equal. So you can't define the equilibrium state with respect to concentration. Okay, with respect to concentration. So you have to define concentration. You have to define chemical equilibrium from rates. What happens in both three parts? The rate of forward reaction and the rate of reverse reaction becomes equals. So RF becomes equals to RB. Here also RF becomes equal to RB. Here also happens that RF becomes equal to RB. Okay, rate of forward reactions then becomes equal to rate of reverse reaction. That is called equilibrium concentration. So how will you know that equilibrium has been established? Okay, there is a very great question, that how you will know that equilibrium has been established. There is only one answer: the amount of the concentration. Check the concentration. Okay, check the concentration. The concentration of products and concentration of reactants. Concentration of products or concentration of reactants. Concentration of products or concentration of reactants. Both are not changing with respect to time. Both are not changing with respect to time. That's why you can say that equilibrium has been established. Okay, so that is the recognition. That is the way of recognition of chemical equilibrium. Okay. So from this state you have said that equilibrium has been established. Okay, clear?
Yes.
If you have any doubt?
No. Sir.
So whenever you have to define chemical equilibrium, you can say that whenever rate of reverse reaction becomes equal to the rate of forward reaction, the system has been in equilibrium state. Okay, the system adopted the state of equilibrium, chemical equilibrium. So it only exists in reversible reactions. Clear? So now come back to the definitions and characteristics of chemical equilibrium, and I will explain that how these chemicals equilibrium are going to establish also. Okay, clear? So here you have a definition. Amir Hamza, how will you define chemical equilibrium? When
Rate of forward reaction.
When the rate of forward reaction, I am going to write here RF because it will take a lot of time. RF becomes equal to RB. When rate of forward reaction becomes equal to the rate of backward reaction, when rate of forward becomes equal to the rate of backward reaction, the system is said to be in equilibrium state, in chemical equilibrium state. Equilibrium state. Clear? Okay. So what are the characteristics of chemical equilibrium? How can you understand that chemical equilibrium has been established? What are the basic characteristics of chemical equilibrium? I am going to write here some characteristics. Okay. First of all, it exists in reversible reaction. Characteristics are macroscopic properties. These are macroscopic properties. These are macroscopic characteristics. Macroscopic characteristics. It exists only in reversible reaction. In reversible reaction, it exists only in reversible reaction. There is no equilibrium in the irreversible reactions. Okay, clear? Number two, it exists only in closed system. In closed system, in which no matter is going to leave out from the system. Okay, clear? It exists only in closed system. Number three, concentration of reactants and products becomes constant. That means they are not changing with respect to time, whether you are waiting from for your whole life. Okay, they are not changed. The concentration will be not changing. Any of reactants or products, not both. You can measure the concentration of only one of the reactants or the products. Okay, clear? Any one of them, and you can say that the reactants, if the concentration of reactants or products is not going to change, you can say that the reaction, the system has been in equilibrium state. Okay?
Okay, sir.
Concentration of reactants and products becomes constant, not equal. Okay? Constant. Okay? I give some illustration regarding this one, that the concentration of reactants and products becomes constant, not equal. Okay, sometime in concentration in equilibrium state, reactants are greater than products, sometime both are equal to each other, and sometime products are very greater than the reactants. Clear?
The rate of concentration is same.
So rate of concentration, rate of reaction is equal. Rate of forward reaction and rate of backward reaction is equal, and the concentration is constant. Concentration of reactants or products is constant. Okay. So here is the number 4 point.
They always have a catalyst.
No, there is not always a catalyst. I don't think so. The fourth point is that pressure condition like pressure, volume, temperature must be kept constant, and concentration must be constant. Okay, whenever you have equilibrium, for example, here I am going to discuss a chemical system that is in equilibrium state. Okay, so this system is in equilibrium state. What will happen if I change the concentration? What will happen if I just add the products on this side? This reactants will the equilibrium will be disturbed. Okay,
Yes.
clear? What will happen if I just change this pot volume? What will happen if I change the change the volume of the pot? All the reactants will be converted into products. The simple one is that the concentration, the equilibrium has been disturbed. Okay, so that is a very clear point, that pressure, volume, temperature and concentration are kept constant. Clear?
Yes.
Okay, so these are also the conditions of chemical equilibrium. Okay, these are also known as conditions for chemical equilibrium. Due to chemical equilibrium, reaction never goes to completion. ब्रेक करने ज़रा वो हो रही है. Due to chemical equilibrium, reaction never goes to completion. Okay?
Yes.
So in closed system there exists a state that is called chemical equilibrium, and due to this chemical equilibrium, reactions never goes to completion. Okay, so there is another question regarding chemical equilibrium, that how do you know that equilibrium has been established? How do you know that equilibrium has been established? So I'm going to write here ways to recognize chemical equilibrium. Ways to recognize chemical equilibrium. Ways to recognize chemical equilibrium. What are ways to recognize chemical equilibrium? So there are two ways to recognize chemical equilibrium. One is physical method and other is a chemical method. Okay, so we can recognize chemical equilibrium by using titration, and the second method is spectroscopic techniques. Okay, spectroscopic techniques, methods. Okay, so these are methods or techniques. These are methods, but there is only one question, that what are the way, what is the basic principle, what is the basic principle to recognize chemical equilibrium. There is only one principle, that whenever equilibrium has been established, the concentration of reactants or products becomes constant. So if concentration of reactants or product any of them, okay, is not changing, is not varying with the time, is not changing with the time, is not changing within equal interval of time, then the equilibrium has been established. Okay, you just have to worry about, you just have to measure reactants, concentration of reactants or concentration of products. Okay, and if these concentrations are not changing with respect to time, then you can say that the reaction is in equilibrium. So how will you measure concentration? You can measure concentration by using spectroscopic methods or titration method. Okay, so there are two ways, by physical method or by chemical method. Okay, the one is chemical method, the other is physical method. Clear? Okay, clear?
Yes, sir.
So concentrations are measured in equal interval of time. If concentration is not changing, the reaction is said to be, the system is said to be in equilibrium state. So there is another question regarding chemical equilibrium, that what are the conditions of chemical equilibrium? Conditions for chemical equilibrium. Okay, what are the conditions of chemical equilibrium? Condition for chemical equilibrium. So there are only 4 conditions. 1, temperature must be kept constant. Okay, temperature is constant, temperature must be kept constant, pressure must be kept constant, volume must be kept constant, and concentration must be kept constant. Okay, clear? All these 4 factors should be kept constant. If you are just changing these conditions, then your system will be no more in equilibrium state. Okay, it will just shift its equilibrium state to another state. Okay, clear? Okay, the equilibrium will be shifted towards the right or towards the left, and there are more complicated stuff here in this. Okay, that is not that is beyond the scope of this course. Clear? However, you have to memorize that temperature should be kept constant, pressure should be kept constant, and volume should be kept constant, and concentration should be kept constant. And all these 4 factors are conditions for chemical equilibrium. Clear?
Yes.
Amir Hamza? Okay. Any doubt?
No, sir.
So our next topic is how chemical equilibrium established. There is another question always asked, always comes in board examination, that how chemical equilibrium established. How chemical equilibrium is established. Okay, I am going to write here an equation that is called SO2 plus O2 gives us SO3. I'm just going to balance this equation. So these are our reactants and these are our products. Clear? Okay. And you know what, in the beginning of the reaction, the amount of sulfur dioxide and oxygen is maximum, and if we allow both these reactants to react with each other, they will react with each other to form sulfur trioxide. Okay, with the passage of time, the concentration of sulfur dioxide and oxygen will be reduced down, okay, and it is converted into sulfur trioxide. Clear? Okay, I'm going to draw here some paragraph here, that if you have concentration is increasing from bottom to top and time is increasing from left to right, here is the concentration of sulfur dioxide and this is the concentration of oxygen. Okay, this is 1 mole, this is 2 mole, this is 3 mole, this is 4 mole, and this is 10 mole. If you have concentration of sulfur dioxide and if you have concentration of such concentration of O2, what will happen? Both these react with each other. And the concentration will be decreased down. Okay, with the passage of time, the concentration of oxygen is also reducing and concentration of sulfur dioxide is also reducing. Okay, so sulfur dioxide and oxygen react with each other to form sulfur trioxide. Concentration of sulfur trioxide increases with the same rate. Okay, and a time comes when the rate of all these three parameters becomes constant, when the concentration of all these three becomes constant. Here you can see that with the passage of time there is no increase in oxygen concentration. Here you see that with the passage of time there is no increase in SO2. Okay, it is not decreasing or increasing anymore. Okay, it is just in straight line. Clear? And here also you can see that SO3 is not changing with respect to time, because no more sulfur dioxide is converted into oxygen. No more sulfur dioxide is reacting with oxygen to produce sulfur trioxide. So in the beginning the rate of forward reaction is very high. They react with each other to produce sulfur trioxide. With the passage of time this reaction is slowing down, and with the passage of time the backward reaction is growing up. Okay, getting faster and faster, and the time comes when the both rate becomes equal to each other. In this way the equilibrium has been established. Clear? So this is the answer of how chemical equilibrium is established. First of all, the concentrations are very much, concentration of reactants are very much, they are maximum, they react with each other. The rate of forward reaction is very maximum. Clear? Is maximum. Okay, and with the passage of time these reactants are reacting with each other to produce sulfur trioxide, and their concentrations are decreasing down, as well as the rate of forward reaction is also decreasing down. Clear? And at the same moment the rate of forward reaction is increasing down, because some of the products of sulfur trioxide are becoming here. Okay, so these sulfur trioxide are also reacting with each other to produce sulfur dioxide and oxygen. Clear? Okay, clear? So with the passage of time the rate of forward reaction decreased down. With the passage of time the rate of backward reaction also increased. Both these reaction rate of both these reaction becomes equal to each other. Okay, clear? So this is the answer of how chemical equilibrium is established, but it comes in especially in Rawalpindi board. This question comes in Rawalpindi board. So, clear? Okay, I hope you have understand all this topic. Yes. Inshallah we will continue these lectures tomorrow. Okay, thank you so much. Any doubt, any question?
No, sir.